Welcome to 12.4. Today we're going to talk about infinite geometric series. So up until this point, we've done a lot of work with finite or series or sequences that you can count and find an actual sum. But today we're going to look at the infinite, so the never-ending geometric series. So it means infinite, remember, never-ending. Geometric means we're multiplying or having a common ratio every time. So let's go ahead and talk about this. So it says the sum of an infinite geometric series. If the absolute value of r is less than 1, which just means if that ratio or your multiplier is less than 1, then we say that our sum that goes to the infinite term is denoted by a sub 1 equals 1 minus r, where a sub 1 is still our first term, and r is still your ratio or your multiplier. So these variables haven't changed one bit this entire time. If the absolute value of that r, that ratio, is greater than or equal to 1, then no sum exists. So we would just say it DNE or does not exist. Okay, so if that r value is 1 or bigger, it doesn't work. So when we look to evaluate this sum, you're going to see this style and some different notations. We know we are looking at an infinite geometric series if our upper bound goes to infinity, which this one does. And remember, this equation is in the style from our day 2 notes, 12 day 2, where it's our a sub 1 times r to the power of n minus 1. And when we're looking at this, we're really looking at that r value. Is that r less than 1 or greater than or equal to 1? And in this case, it is less than 1, which allows us then to use our formula from above, this guy right here. So our r is 0.8, our first term is 5, so we can substitute it in and say that the sum of our infinite series is equal to 5 over 1 minus 0.8. And once again, use your calculator to help you out on this, but then that is the same as 5 divided by 0.2, which is, in fact, 25. And these ones are the easier ones when they're kind of just set up for you already in summation notation. The next one is a little bit harder. So once again, you got to look at your notation. The dot, dot, dot represents it goes to infinity. Okay, and that's from our earlier notes. It goes to infinity. So we got to figure out what are we multiplying by every single time. So since it's geometric, it's all multiplication. So when we look, our first term is 1. Our second term is negative 3/4. Well, lucky for us, if our first term is 1, whatever you multiply it by is going to be that number. So since it goes from 1 to negative 3/4, that instantly tells us that our rate is negative 3/4. Our first term is 1, so therefore we can substitute in and solve. So this would be the same as 1 over 1 minus negative 3/4, which is going to give us the same thing as 1 over 1.75, or since it's in fraction form, I'll just call it 7/4, which if you just put this into your calculator, you should get 4 over 7. So it's very, very simple as we're going through and solving. You're just trying to identify. All right, for the next one, we have, once again, we're going to infinity, which tells us we can use this geometric term. Our first term is 2. Our ratio is 5 over 3. Now, at this point, you should notice that our ratio is bigger than 1, so we can just instantly say this does not exist. And that's it. For our next one, our first term, we get is 2. The dot, dot, dot tells us we're going to infinity. And we got to figure out, okay, how do I go from 2 to negative 4? 2 times what gives us negative 4? And you should say -2. And once again, since that R, remember we're going absolute value of R, so it doesn't matter if it's positive or negative. But since it is greater than or equal to 1, this just does not exist. So we're really looking at that R value to help us determine where we're going. Then the last two problems are word problems, so let's dive in and figure out what's important. It says a pendulum that is released to swing freely travels 18 inches on the first swing. So from that first sentence, we already know our first term is traveling 18 inches. On each successive swing, so the swings following, the pendulum travels 80% of the distance of the previous swing. What is the total distance the pendulum swings? So we know the first swing is 18 inches, and then every single swing after that is only 80% of the previous one. Well, if it's only 80%, that means your rate is 80% or 0.8. So then, since our R is not greater than or equal to 1, we can go ahead and use our infinite geometric series, S sub infinity, and that's going to be equal to 18 over 1 minus 0.8. And that will tell us that our pendulum is going to swing about 90 inches before it comes back to rest. Next, or to finish, we have Fred the Flea is on the pendulum having a grand old time. His first swing of the pendulum is 40 centimeters, and it only swings 75% of the distance on each successive swing. What is the total distance that Fred the Flea is traveling on the pendulum? So very similar. Once again, the first swing is 40 centimeters, and each successive swing is 75% of that, so 0.75. And once again, you got to look at that R value. It's less than 1, so we can go ahead and use our infinite series and get 40 over 1 minus 0.75 is going to give us that Fred is actually swinging a total distance of 160 centimeters, and that would be finished. Have a good day.